in order to do this next problem set that we're dealing with, we have to understand some concepts in order to work with perfect square trinomials and difference of square trinomials for factoring. So we got to recall what we were doing in 4.1 all the way up to 4.3. And with 4.1, we dealt with the expansion of polynomials. And we often saw something that dealt with expanding and simplifying. But in particular, we looked at a special expansion. So if we have 2x plus 5 all squared, we ended up with something that looks like this. Now, when we apply FOIL, the FOIL would mean that 2x would be applied to everything in the last bracket, and we would get something like this for the first half of our equation. Then we would take the 5, which is in the first bracket, and then apply it to everything in the secondary equation to ensure that the entire quadratic is expanded. And we end up with 10x plus 25. Now, once we've done that, we have to collect our like terms, which are the two center terms. So we end up with 4x squared plus 20x plus 25. Now, I remember a while back, I taught you a ridiculous lesson. I basically started the lesson by starting with a song. Square the first, square the last, multiply and double. And this was directly in response to this type of question. We call this type of question a perfect square. So you'll notice 4x squared plus 20x plus 25 comes from that quantity up there. And you'll notice that when I square the first term in the bracket, so 2x all squared, if I squared the whole thing, would be 4x squared, which is what we expect. Now, when we square the last, we end up with this. If we square the last term, it's 5, and we end up with what we expect, 25, as the last term in our equation. Now, for the multiplying and double, that always was referring to the center portion of our expansion. And that was given by these two here, the 2x and the 5. 2x and the 5 gives us 10x. 10x times 2 gives us the center term of our equation. And at the time when we were doing our work, we actually called this the perfect square trinomial, where any trinomial, doesn't matter what it is, if it looks like this, a plus b squared, we end up with this equation, a squared plus 2ab plus b squared. Now, we have worked going this way so far. We expanded going this way so far. And in our last unit, we started going the opposite way. So now we're actually going to start from a squared plus 2ab plus b squared, and we're going to go back that way. And what we're going to do is we're going to use the fact that we remember that a squared plus 2ab plus b squared is a perfect square trinomial. And we can use that to come up with the stuff on the left side. Now, today's lesson is factoring a perfect square trinomial, okay, and the difference of squares. But this is part A, the perfect square trinomial. So the characteristics of it, if you think about it, the ax squared, the ax of any even number, of any even exponent number, plus b times 1/2 of the even number that you had before, plus c, is a perfect square trinomial, where a is a perfect square, b is equal to the square root of those two numbers, plus c. Plus the square root of c. And the thing is, this number could be either positive or negative, and I'll be showing you tricks to remember what these values are. And remember that the c squared, the last square term, is also a perfect square. So remember, Every time we do these problems, we always try to remember that we got our silly little song. Our silly little song, which is this. Square the first, square the last, multiply and double, and that is in regards to this specific equation, which I've just turned around, because we're always going to start with a squared plus 2ab plus b squared, which will give us bracket a plus b all squared. Now, let's talk about the work that we're going to do for this. So, basically, we're going to determine if each of the following is a perfect square trinomial and factor if it's possible. So let's start. When we have this problem, A, x squared plus 10x plus 25, the first thing I'm going to do is I'm going to assume that it might be a perfect square trinomial. And in order to investigate that, I have to remember my song. My song goes and tells me, hey man, we had to square the first and we had to square the last. So if I want to undo that, I literally have to go back and say, okay, the square root of that entire x squared term is x. The square root of 25 is 5. Now remember, it said we had to multiply and double to get the center term. And 5 times x is 5x. And 2 times 5x gives us 10x, which is what we want. Oh my goodness, it works perfectly. So that means our equation is x plus 5 squared. I'm going to give you a big hint in order to save our work here. So remember, the x squared term turns into x. The 25 turns into the 5 because we square root. But the center term gives us information on what our bracket should have. Remember that when we square root something, we have either plus or minus whatever that number is. In order to determine what our plus or minus is going to be, all we have to do is look at the center term, which goes and tells us right away what our term is, whether it is positive or negative. So take from this that the sign is determined by the center term in our equation. The endpoint square root to give us x and 5 in this case, and we have to square it. Now, for our next problem, we have 4x squared minus 24x plus 36. Now, anytime we do factoring, you always need to check to see if there was a GCF. The GCF in this problem is 4, so let's pull that out right away. Now, what's left over? We're left with this bit of ugliness. And we say, you know what? Maybe we don't have to go and use factor by grouping or the Berry method in order to solve. So let's just quick and check. If we take a look at the square root of x squared, we get x. If we take the square root of 9, we get 3. And if we take these two numbers, 3 and x, we get 3x. Multiply it by 2, we get 6x. Perfect. That's great. Now remember, we start with our next line. It's going to still have our 4 in it, but our bracket is going to be this. It's going to start with an x and end with 3. And the sign comes from the center term. And it just turns out to be -3. And it's all squared. And we are done. Like dinner. So now, what I want you to do is I want you to try this next problem. If you take a look at C, you've got 9x squared plus 48xy, and this should have a y squared term in it. Now, what I want you to do is I want you to see if this is a perfect square trinomial and make it work. Okay? So right now, we're going to have, if we look at the square root of 9x squared, the square root of 9x squared is literally 3x. So this is the square root of 9x squared is 3x. The square root of 64y squared is the following. 64y squared is going to be 8y. Now when we take 8y and 3x and multiply them together, you're going to get, you guessed it, positive 24. Now positive 24 times 2 based on our song, square the first, square the last, multiply and double will give us 48xy. So now we'll write at the beginning of our problem, we're going to get 3x. At the end of our bracket, we're going to get 8y. And we need to remember that the whole thing is squared. But where does the sign come from? The sign will come from the center term. The center term has a positive sign on it, so we literally match it in this case. And we're done.